This is a fully interactive AI workflow builder. It has 5 node types, a drag and drop canvas, color-coded branching, workflow validation, simulated execution, and save and load support. It validates the workflow, runs each node in sequence, evaluates the condition, and follows the selected branch. And when I deliberately break the workflow, it doesn't just display a generic warning. It identifies 5 separate errors and 1 warning, including unreachable nodes and a trigger with no outgoing connection. MiniMax M3 built this application from one detailed prompt. It planned the project, created 3 files, tested the application in a browser, discovered 4 bugs, and corrected them without waiting for additional instructions. Then I gave M3 a screenshot of its finished application. It correctly interpreted the workflow and identified several specific UX improvements. So in this video, we'll test M3's coding, agentic debugging, and native multimodal capabilities through one practical project. We'll also look at how M3 works under the hood, how it performs on benchmarks, and whether these results make it a practical option for developers. A lot of interesting stuff here. Let's get into it. Alright, so quick background on what M3 actually is. MiniMax M3 is the first open weights model to combine 3 frontier capabilities in one package: coding and agentic reasoning, a 1 million token context window, and native multimodality. And when I say native, I mean multimodal training from step 0 with over 100 trillion tokens of data. This isn't vision bolted on as an afterthought, it's baked into the foundation. On the benchmark side, it scores 59% on SWE Bench Pro, 66% on Terminal Bench 2.1, and 74.2 on MCP Atlas. On BrowseComp, which tests autonomous browsing and information retrieval, it hits 83.5. That's higher than Opus 4.7 at 79.3. For an open weights model, those are serious numbers. And it's open weights on Hugging Face. Around 428 billion total parameters with roughly 23 billion activated. So this is a sparse mixture of experts architecture, which means it's large but efficient. Now for this video, I'm running M3 through Hermes Agent. Hermes is an open source agentic coding framework that supports multiple providers. Setting it up with MiniMax is straightforward. You select MiniMax as the provider, choose M3 as the model, authenticate with your API key, and you're in. M3 connects, the status bar shows MiniMax M3 with the full 1 million token context window available, and you're ready to go. If you want to use M3 directly, you can access it through the MiniMax platform. I'll leave all the links in the description, including the API documentation and the Claude Code integration guide. Alright, now let's build something. So here's the task I gave M3. Build a complete interactive AI workflow builder application. Think of something like NA10 or Zapier, but don't copy their UI. I wanted a visual drag and drop canvas, 5 different node types, each with its own configuration panel, a validation engine that catches errors before you run anything, a simulated execution system, save and load functionality, and a starter workflow that actually works out of the box. That's not a simple prompt. It's a full specification with 10 sections of requirements. And I pasted it in and let M3 go. No hand holding, no follow-up instructions, one shot. Now watch what happens. M3 starts by planning the file structure. 3 files, an HTML shell, a CSS style sheet, and a single JavaScript file for all the application logic. No build tools, no dependencies, no frameworks. Pure vanilla code. And it's not just generating code blindly. You can see it working through the requirements systematically. Now here's where it gets interesting. M3 didn't just write the code and hand it over. It actually tested its own work in a real browser. And when it found bugs, it fixed them. 4 bugs discovered and resolved during the build without me saying anything. First, there was a CSS specificity issue where a modal was showing when it shouldn't. M3 added a hidden attribute override. Second, the empty state message was positioning in the wrong place on the canvas. M3 moved it to the correct parent element. Third, The execution log was producing duplicate entries for each node. M3 refactored the simulator to update entries in place. And fourth, the AI simulator was always returning negative sentiment, which meant the false branch of the condition node could never fire. M3 added positive and neutral responses so both branches work naturally.
So the final output: 3 files: HTML at 8 kilobytes, CSS at 26 kilobytes with a proper design token system, custom colors for each node type, animations for running and completed states, and the JavaScript at 55 kilobytes, organized into 17 clearly labeled sections, zero dependencies, production quality structure. And this is what you get: a fully working application that loads in any browser. Dark theme, left sidebar with a node palette, central canvas with zoom controls, right panel for node configuration, execution log at the bottom. It looks professional and it works. Alright, so M3 built the app, but remember, one of its three frontier capabilities is native multimodality. So I wanted to test that too, and I had an idea. What if I took a screenshot of the application M3 just built, fed it back to the model, and asked it to analyze its own work? So I did exactly that. I gave it a screenshot and asked it to identify the application, describe the workflow, spot UX issues, and suggest improvements. And the response was genuinely impressive. It correctly identified Flowforge as an AI workflow builder. It described the entire 5-node workflow accurately, including the condition branching logic. It even noticed that the Chrome tab had Ask Gemini visible in the corner. But the real value was in the UX feedback. It pointed out that the config panel has no template or token picker for referencing upstream node outputs. It flagged the asymmetric branch geometry between the true and false paths, and it suggested adding a variable chip pattern, symmetric branch anchoring, and per node run history indicators. These aren't generic suggestions. These are specific, actionable improvements from a model analyzing its own code output visually. That's coding plus vision plus reasoning working together in one loop. Well, the starter workflow works, but that's a workflow M3 itself created. The real test is whether the application handles workflows that a user builds from scratch. So let's stress test it. I'm building a new workflow from scratch, a high value order router. The idea is simple. A form submission comes in, an AI model classifies the order value, a condition node checks if it's high value, and then it routes to either a Slack alert for the sales team or an email confirmation for standard processing. Trigger node set to form submission. AI model node configured to classify order value with a temperature of 0.3. Condition node checking if order value equals high. Slack node posting to a high value orders channel. Email node sending to orders at example.com. Now I connect them. Trigger to AI model. AI model to condition. Condition true, path to Slack. Condition false, path to email. You can see the connections render with directional arrows. Green for the true branch, amber for the false branch. Hit validate. Green, valid. 5 nodes, 4 connections, everything checks out. Run it. And it executes through the full chain. The nodes light up one by one as they process. The condition evaluates, picks a branch, and the correct endpoint fires. Run it again. And again. Both branches fire correctly across multiple runs. The execution is not hard-coded. It's actually evaluating the condition each time. Now let's break it on purpose. I'll remove the connection between the trigger and the AI model. Hit validate. 5 errors, 1 warning. AI model is not connected. AI model cannot be reached from any trigger. Condition cannot be reached. Email cannot be reached. Slack cannot be reached. And a warning that the trigger has no outbound connection, so the workflow won't do anything. Every single error is accurate. The validation engine M3 built doesn't just check for obvious problems. It traces reachability from the trigger node through the entire graph. That's real logic, not surface level checks. Reconnect everything, save the workflow. It appears in the saved workflows list in the sidebar. Now hit new to clear the canvas. Hit load. The workflow comes back with all nodes, all connections, and all configurations intact. Clean round trip. So the application handles user-built workflows, catches real errors, executes with proper branching, and persists data correctly. Two minor things I noticed. The execution log panel didn't surface visibly in the UI, and some node titles truncate slightly on the canvas. But overall, this is solid output from a single prompt. Now quickly,
The reason M3 can handle a 55 kilobyte JavaScript file in a single context window without breaking a sweat is its architecture. MiniMax Sparse Attention, or MSA. This is a proprietary sparse attention mechanism designed specifically for ultra-long context. The standard transformer attention scales quadratically with sequence length. Double the context, quadruple the compute. MSA avoids this by being selective about which tokens attend to which. The result is a model that supports up to 1 million tokens with a guaranteed minimum of 512,000 while maintaining strong inference latency and throughput. This is the infrastructure that makes long-range agent tasks, long-range coding, and long video understanding possible in a single model. And with the open weights release, this architecture is now available for the community to study and build on. That's a first for this capability level. Alright, let's talk about access and pricing because this is where M3 gets interesting for daily use. MiniMax offers 3 tiers. Plus at $20 a month gives you roughly 1.7 billion tokens. Max at 50 gives you 5.1 billion and Ultra at 120 gives you about 9.8 billion. What's different here is that all tiers include the full model family: M3, M2.7, image, speech, music. One pool, everything included. For the price point, that's one of the highest token quotas I've seen. So here's where I landed. One prompt, 3 files. A working application with drag and drop, branching logic, validation and persistence. 4 self-caught bugs and a multimodal test where it analyzed its own UI and gave real feedback. All from an open weights model starting at $20 a month. There are a couple of minor UI quirks, but for the price and the capability, especially with that million token context window, M3 is punching well above its weight. If you're a developer looking for strong coding, long context, and native multimodal in one model, M3 is worth trying. Links are in the description, including the token plan with a 12% exclusive discount. Give this a thumbs up if it was useful and subscribe for more. I'll see you in the next one. Take care.